All right, so what we're looking at is we put our normal points of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we looked at this value first, and we said that that's going to be a horizontal stretch by 2. So I had to take each of my x's and I had to double them. And now I'm going to look at this, and what is that going to do? That's going to shift us what? Right, pi over 2. So all of these are going to go to the right, pi over 2. Once I see that pattern developing, it makes it a lot easier. See the pattern there of 1 pi over 2, 3 pi over 2. Math's all about patterns. Then I want to look here and think about what are the normal values for sine. What are they, everyone? 0, 1, negative 1, 0. That's it normally. So now we're going to look here, third, and that's going to be our amplitude as well as our vertical stretch of 3. So all of these y values then are going to get multiplied by 3. Negative 3. So we did that. And then the last thing we want to do is this. We want to shift it up 2. So add 2. And I don't even care if you plot the points that much. We'll go ahead and do it, but on your quiz, I'm just going to be asking you to find the 5 key points, because if you can do that, you can certainly graph. So at pi over 2, we're going to be at 2. At 1.5 pi, we're going to be at negative 1. 2.5 pi, we're at 2. 3.5 pi, we're at 5. And 4.5 pi, we're at 2. So we get that. If you're ever asked what the sinusoidal axis is, it's this axis right here. It goes through the middle of it. That's the sinusoidal axis. It's also called, I think some books call it like the line of symmetry and things like that. All right, if I wanted to check it, I'm just going to check it real quick for you. You don't have to do this on your calculator. I'm just going to do it quick. Negative 3 sine 0.5 parentheses x minus pi over 2 plus 2. Check my window setup. I'm starting at pi over 2, and we're going up by pi every time. And so now, if I check this, the points should be correct. 2, negative 1, 2, 5, 2. Good. All right. That was quick, but let's go down here now. We're going to do numbers 1 and 2 together. You guys will do 3 and 4, kind of using the same thought process. I want to graph y equals tangent x. We could use our graphing calculator, but I'm going to expect you to know what this looks like without having to resort to using that calculator. So what I can do if I'm not going to use it, the calculator, is I'm going to think at negative pi over 2, right here. What is this point? Anybody know? 0, negative 1. So the tangent then at negative pi over 2 is going to be y over x. So what's that going to be? Undefined. If y is undefined, we get a vertical asymptote. At negative pi over 4, that's right here. On the unit circle, I could do the unit circle. That point would be radical 2 over 2, negative radical 2 over 2. So what's y over x going to be there then? If I do negative radical 2 over 2 divided by positive radical 2 over 2, negative 1. At 0, this point is 1, 0. So what's y over x? 0. Pi over 4 is 45 degrees. I'll just draw a triangle this time. For 45 degrees, I go 1, 1, radical 2. And so what's opposite over adjacent going to be? 1. And then at pi over 2, we're up here. This point is going to be 0, 1. And what is y over x? Undefined, so another vertical asymptote. Okay, so what that tells me then is here at negative pi over 2, I've got a vertical asymptote. Positive pi over 2, I've got a vertical asymptote. How far apart are those from negative pi over 2 to positive pi over 2? Pi units. So my next one is going to be at 3 pi over 2. What's the pattern? What's the next one? 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Plotting these points, negative pi over 4, I'm at negative 1. This I'm at 0. Here I'm at 1. That means my function is going to always be going up. Just a quick sketch. It's going to look like that. If I wanted to check it on the graphing calculator, I can do tan x. I'm graphing it from, on my window, negative pi over 2, and we graphed it all the way up to 7 pi over 2. Just changing my window so we can see it a little better. So here's the way it looks. It goes up, and continues that pattern forever. It's a periodic function. All right, let's do the secant graph. Same kind of thing. Think of our unit circle. Right here, this point's 1, 0. So at 0, secant is a reciprocal of cosine. So here's our cosine. What's the reciprocal of 1? 1. What is the pi over 2? That point is going to be 0, 1. So what's the cosine? The cosine 0, and what's the reciprocal? Undefined, so we have a vertical asymptote. Pi, what's the cosine? What's the reciprocal? 3 pi over 2, what is it? 0, 1. So cosine is going to be 0, and the reciprocal is undefined. And what do you think 2 pi is going to be? Look at the pattern. 1, undefined, negative 1, undefined, 1, undefined, negative 1. All right, so wherever I have these undefined, I'm going to have a vertical asymptote. Every time I have an odd multiple of pi over 2, I've got a vertical asymptote. I know at 0, I'm at 1. Do you know the basic shape of a secant? Does anybody remember what they look like? They're kind of U's, aren't they? We never go inside that cosine curve. It actually goes like this because it's reciprocal. So there's the way our secant looks. Last year you may have done some transformations with these, but we're not going to. I just want you to be able to know what the basic graphs look like. I'm showing you how you could come up with them without the graphing calculator, but most of the time we'll even be allowed to use it, but just kind of a general sketch. So you'll go back and do these two. Okay. Arcsine and sine to the negative 1. This notation means we are looking for a single angle, just one angle, not two like usual, that has this ratio of m, or y over r. If we're doing arc sine of m, arc cosecant of something, or arc tangent of a ratio, then our interval is going to be from negative pi over 2 to pi over 2. Every answer we choose has to be between negative pi over 2 and pi over 2. Is 7 pi over 4 in between those two? 7 pi over 4. 7 pi over 4 is 1 3/4. Is 1 3/4 in between negative 1/2 and positive 1/2? So what would be another answer for that? Instead of saying 7 pi over 4, what could I call it if I go that direction? Say that a little bit louder, Tyler. Not negative 3 pi over 4, it's actually just negative pi over 4. Negative 3 pi over 4 would be over here. Okay, so that's what we're going to have to think about. Instead of using 7 pi over 4, we would have had to have said negative pi over 4. What's another name? Say this had been, let's call it 5 pi over 3. Instead of calling this 5 pi over 3 because that's not in that interval, what's another name we could use? Negative pi over 3, right? Okay, so which quadrants are we going to use? For 0 to pi over 2, that's in quadrant what? 1. And what about from 0 to negative pi over 2? That's in quadrant 4. Here's where it gets tricky, though. Even though we can use quadrant 4, I can't use names like 7 pi over 4, 5 pi over 3, 11 pi over 6. I can't use those names. I have to use other names for them. And we'll do some problems like that. For all of these functions, arc cosine, arc secant, arc cotangent, every answer has to be between 0 and pi. What quadrants are those? 1 and 2. These are going to be easier. These are easier than that. Okay, let me come down here and do a couple of examples. Let's say we're doing arcsine of negative radical 3 over 2. This is saying what is the one angle that has a sine ratio of negative radical 3 over 2, and the angle must be in between negative pi over 2 and positive pi over 2. Which quadrant am I going to use if I have sine negative? Am I allowed to use 3 based on this? So what am I going to use? Quadrant 4. So I have to use quadrant 4. Sine is opposite over hypotenuse. I don't want to go this way with it, though, for this angle. Remember in the fourth quadrant how we're going to go in this direction? So what's that answer going to be? 300 degrees, but we want to be in radians, and we want to use something between negative pi over 2 and pi over 2. Negative pi over 3. You guys see why that would be the one correct answer? Because that would be in between negative pi over 2 and pi over 2. All right, let's try another one. What about arc cosine of negative radical 2 over 2? Look at arc cosine. Look at what we're allowed to do between 0 and pi. 0 and pi. Which quadrant is going to have cosine negative between just 0 and pi? Quadrant 2. So I'm going to draw a picture. Now what's another name for radical 2 over 2? 1 over radical 2. So I can think of this as negative 1 over radical 2. And that's a 1, too. 1 as well, I should say. So what's this missing angle? 45 degrees. What am I going to call this angle if it has to be between 0 and pi? 3 pi over 4. Good. So like I said, these are pretty easy. These are like you're used to. But how many answers am I putting for these? Just 1. Okay? You know that other type we did, we always had 2, but these are just 1. All right, you guys try this one now. Arcsine of negative radical 2 over 2. And remember, this means the same thing as this. It could have been written like this. It means the same thing. Grace, Titus, what do you think?
Negative pi over 4.
Do you guys agree? Negative pi over 4? Good job. That is correct. Okay. Now, I want you to think about this. What if this had just been positive radical 3 over 2? Then what would our answer have been? Pi over 3. If this had been a positive, what would this answer be? Just an easy answer, guys. Just in the first quadrant. Pi over 4. And if this one had been a positive, our answer would just be pi over 4. Good. Okay, last thing here. I'm not going to do this whole thing with you, but I'm going to help you set it up. On February 10th of 2012, high tide in Boston was at midnight, and the water level was 9.9 feet. I'm going to make a chart here. So midnight is going to be time 0. The water level was 9.9. The water level at next high tide, 12 hours later, was again 9.9 feet. So 12 hours later, we're again at 9.9 feet. The low tide water level, which occurred in the middle of the high tides, so in the middle of the high tides, so how many hours would that have been? So 6 hours. It tells us that it was 0.1 feet. The curve representing the data is given by a sine or cosine curve. Find an equation for water level in Boston as a function of time. Now, this data, I only have 1, 2, 3 points. How many points do we like to have generally to write a curve? 5. So I'm going to squeeze in some other points. I'm going to say 0 is 9.9. What about at 3? After 3 hours, what would it have been? How can I find the middle of two numbers? What do I do to find the middle of two numbers? Add them and divide by 2, right? So what's 9.9 plus 0.1? Divided by 2. So after 3 hours, it would have had to have been 5. Then at 6 hours, it was 0.1. 9 hours, what is it? 5. And then at 12 hours, what is it? 9.9. And I want you to come up with the curve that would pass through those points. So a sine or cosine curve that would represent the water level compared to the time. So that's your homework. Finish up these notes. You got 2 there, 10, 11, just 11 problems. Good job today.